Welcome to the video. In this video, we are going to look at problem number 47 of chapter 22. In order to solve this problem, we are going to need equation 22.6.1 and also the set of kinematic equations which you can find in chapter 2 on page 25. The problem says, suppose you have a proton gun which has a built-in electric field of 2.0 times 10 to the power of 4th SI unit. Then what will be the acceleration the proton gun will produce on a proton? To get that, all that we have to do is to use equation 22.6.1 along with the equation for Newton's law. So, since we have a proton in an electric field, that proton would experience an electric force which is equal to the charge multiplied by the electric field. In that calculation, you can see that the charge carried by a proton is positive 1.6 times 10 to the power of negative 19th. Since the problem did not specify a direction for the electric field, we'll just assume that that field is pointing to the right. Now, according to Newton's law, the proton would experience an acceleration. And we can calculate the acceleration by moving the proton mass to the right hand side. And that will be the answer for part A. In part B, they're asking what speed would the proton get if the proton is accelerated through a distance of 1 centimeter. Now, in this question, the time t is not given. So that first equation would not apply. And any of the equations that has t in it would not apply because for the problem, we do not have any information for the time of travel. And that will leave us with just one equation that we can use. And since here we are talking about a proton gun, we can assume that the initial speed of the proton was 0. From here, we can plug in the value for the acceleration and the displacement. And after that, all that we have to do is to take the square root and we will obtain the answer for part B. And that completes this video.